So we can see that this part should be 2 marks. First, state your conclusion. Is it reliable or not? So you can say, no, it is not reliable because 10.3 hours is outside of the data range given. Next, normal distribution. Let me clear my calculator, and we definitely need just a simple calculator to do the normal distribution. The daily January temperature of the case is normally distributed with a mean of 34 degrees Celsius and a standard deviation of 3. Calculate the probability that the temperature on a randomly chosen day in January is less than 39 degrees Celsius. And then calculate the expected number of days in January that is more than 39. On a randomly chosen day in January, the probability that the temperature is above certain temperature is 0.7. So just by looking through the question, then first thing you need to remember is make sure you do sketches, that you know what you are dealing with, have a visual for these sort of question. And the other thing is, usually in Part C, you will be given the probability, and then you need to work backwards. So Part A, we have let's draw the sketch. First, draw a bell-shaped curve. Where is the mean? 34 degrees Celsius and a standard deviation of 3. So over here, 37, 31. So this is at least a start of how you can approach this. If you have to continue, you only need to do 3 standard deviation away from the mean. So that would be 28, that would be 25. Just so that you remember, each side is 0.5, or you can think of it as 50% on each side of the bell-shaped curve because of the symmetrical properties. Well, 39 degrees is right about here. And it says we need it to be less than. So that's perfect because our normal distribution curve is read from the left to the right, like this. So we want it to be less than. This is what we need. This is the area. The expectation of your answer has to be greater than 0.5 because it's more than halfway. Right? Okay. Good. Now we need to use our calculator to evaluate it out. What would it be? Ooh. We need to go to Menu, Statistics. This time, these are distributions, so we need to go to Distributions. We need our normal cumulative density frequencies. As you can tell from the diagram, we are from all the way from the negative, the lower bound is that small, and then all the way up to 39. So you put 39 degrees, state the mean. This symbol mu means the mean, sigma means the standard deviation, so you put it there. That's the probability. So part A, the answer is 0.952. 3 significant figures will do. Part B. Calculate the expected number of days that it will be more than. Now, more than, if I compare it with the diagram at the top, so 34, more than 39 is this tiny little tail area. Now, since the area of the bell-shaped curve is equal to 0.5 plus 0.51, we can quickly find that by doing 1 minus the probability we got at the top, 5.2. So what you do is can do on your calculator 1 minus the answer. Now, you can recall the answer by doing this, control minus sign to get the answer. Press enter. So the probability of the temperature being higher than 39 degrees Celsius is this. But we haven't actually answered the question. We only done part of it because we need the number of days, the expected number of days in January. So how many days are there in January? 31. So the expected number of days must be 0.0478 times 31. So using the calculator value, so answer times 31, you will get 1.48 days. So about 1.5 days, you will get temperature higher than 39 degrees Celsius. Part C. Part C, it says, well, for a certain temperature to be above, so the key is to look at, is above. If we miss this, it would be quite devastating. So 34 is the mean. For the temperature to be above certain degrees is 0.7. Now, this side and this side, if you mark the temperature here, then more than we're looking at this tail. This tail cannot possibly be higher than 0.7, right? So it doesn't make sense. The temperature is over here on the right-hand side of the bell-shaped curve. It has to be over here. So I'm going to clear that bit. It's actually 0.5 plus 0.2 more here. So this area is 0.7. 0.7. So you need to rely on inversing the normal distribution to find out at what temperature is this going to happen. But your calculator cannot figure it out. Things that are from the right-hand side, it has to be going from the left, coming up from the left. So what you have to do is to figure out this, and it is 0.3. So you're working out from the left to the temperature. Instead of above T Celsius, it is below T Celsius. So you interpret it as 0.3. The probability is 0.3 below this to help yourself out to answer this question. Go to menu, statistics, distribution, this time inverse normal. The area is 0.3, 34, and 3. The temperature is 32.4 degrees Celsius. Now, as you can see, these questions, there are 2 marks each. 1 mark would be looking at what you have drawn. This is actually your method, because we can't see what you key in the calculator. If you just write that down and say if you round it wrong, I've warned you many, many times, it would be very bad. Because if you round it wrong, they consider you completely wrong. So the diagrams are very important when it comes to solving normal distribution questions. So we've done a short questions. Now we're going to try a longer question. So make it bigger, first of all. It says a group of candidates doing chemistry exam and physics exams. Why do they like chemistry and physics so much? The candidates' marks in the chemistry exam are normally distributed within a mean of 60 and standard deviation of 12. Draw a diagram. Okay, draw. Write down the probability. So click on mark question. Find the probability. So 2 marks meaning it's more than just 1 step. We better support it with a sketch. As again, part D, find the probability less than, so 2 marks. And then determine whether or not the physics compared to other tentative. Well, we'll get to that. So as you can see, these are, especially the last part, is 3 marks. Let's try. So part A, it says we need to draw a diagram to show the information. So we first have the chemistry test only. So we draw a bell-shaped curve. The mean is 60. The standard deviation is 12. So you can write this 48. Bam. Just to show. Part B, write down the probability that a randomly chosen candidate who set the chemistry examination score at most 60 marks. So at most 60 marks. Well, this side is 0.5, this side is 0.5. 60 mark is the mean, so just halfway through. At most, that's 50%. The probability is 0.5. Well, of course, you can say half or 50% as well. Part C. Hyun-jin scored 80 marks in the chemistry one. Find the probability someone scored more than him. 60, 72, 80 about there. And we want it to be more. Continuing from, remember what I said about it's cumulative only from the left to the right. So in order to figure this area out, we need to do cumulative from, actually your calculator does it for you. Forgot about that, so scratch that. Let's go to your calculator. Menu, stats, distribution, CDF. This time your lower bound is at 80. Change it to 80. And then your upper bound is very high. So make a very large number. 60 is your mean and 12 is your standard deviation. Click OK. That's more like it. So it's a small 0.0478, like that. Whoops, that's part C, sorry. Another thing in exam, you do need to make sure you label the parts very clearly. Part D. So now it's for the physics exam.
Wait for another 1 minute.
Another one. So this time it is 63 is the mean, 73, 53. This is for the physics exam. Now find the probability that someone scored less than. This time again is 80. So say 80 here, and we want it to be less than. Straight on to your calculator. CDF, lower bound, upper bound, mean, standard deviation. So the answer here this time is 0.955. D. Determine whether Hinjin's physics marks compared to other candidates is better than her mark in chemistry, and give a reason for your answer. What do you think? Right, to answer this question, just realized I have reduced the screen so small you might not be able to tell. It says here in part E, determine whether Hinjin's physics marks compared to other candidates is better than her mark in chemistry, and give your reason. So technically it's asking you to compare the two probabilities when the probability of someone that you selected has a higher score than she does. So if you look at her, if I have it side by side, or no, up and down like this one is her chem one, this one is her lower one. Now they deliberately set it to both at 80. This is the probability that you select someone that person will have a higher score than 80, meaning doing better than Hinjin. In part D, what you have calculated is probability of people getting lower than she has. So you need to reverse this one. So you need to do 1 minus your previous answer. For this area, this tail area, you have 0.0447. So as you can see, big 7. The probability that you select someone doing the physics exam having a higher score than Hinjin is 0.0447, which is less than chemistry. So the probability of someone doing better than her is lower. And therefore the conclusion is that she has done better in the physics exam than in the chemistry exam. So because 0.0447 is less than 0.0478, therefore she did better in physics, or she has done better in physics. Part F. To obtain an A grade, a candidate must be in the top 10%. So find the minimum possible mark to obtain a grade A. Round your answer to the nearest integer. Part E. So draw a diagram. You have physics. So physics is 63. So you have 63 here. If you are in the top 10% range, then you would get an A grade. And so what mark is this for it to be possible? So because it's definitely using inverse normal distribution, but you need this. So you need to find out the inverse of this area. 0.9, 63, and 10. And then, okay. The mark is 75.8155. So round it to the nearest integer, you will get 76.